This begins 1.7, and what we'll be doing is modeling with tables. So just to give you a heads up, tables are extremely useful, especially if you're asked to graph a problem. You can obviously make a table of x values and y values, and you just get to choose whichever x values you want. It doesn't always work. For instance, like the square root function of x, let's say we had this type of problem. If you don't know what this graph looks like, well, you can start plugging in values for x. Well, if you try to plug in -1, you cannot square root -1, so you would get no solution. This is my symbol for no solution. You may remember that from an earlier video. Otherwise, you can start plugging in other values for x, like 0. Well, the square root of 0 is 0. The square root of 1 is 1. You might want to avoid the square root of 2 because that's not a perfect number. You can use a calculator, but if you're using a calculator, you might as well use the calculator. So you might jump to 4 for the next one. Well, the square root of 4 is 2, and then you can plot those points like 0, 0, 1, 1, 4, 2, and then you can see the graph. Now, I'm well aware that a graphing calculator could do this problem for you. If you were to type in y equals the square root of x, and you can actually see these values, and if you click on the graph, you can see when x is 1, y was 1, when x is 4, y is 2, and you can find the next one. It actually goes off the graph. I mean, you can't see it. I could obviously move the screen over and you could see it. But there's this cool little tool right here in Desmos. I'm in Desmos, by the way. Just type that into your search bar. You'll find it. And you can hit convert to a table. And everything I told you about, and you can just hit enter to scroll down. Let me hide this from you. And you can get all of the values that you want. And this graph actually puts the points on here for you as decimals, but it's still useful. So let's get back to our notes. And hopefully I've convinced you the point of having a table. So here's a table. Pause the video, read the problem, interpret it, things like that. So the first thing that Ashley wants you to do for her is to write an equation to come up with how much she's going to get paid. Now, they tell you that she's going to get paid $2,000 if she sells nothing at all. So she's getting $2,000 a month, which in today's standards is not very much money if you're thinking, wow, I want that job. But then she also gets a 6% commission, which you write the decimal down as a, the percent down as a decimal. Sorry that I thought I grabbed the eraser. There we go. And you multiply that by however many sales she has. So I'm just going to use the same Desmos I just showed you. And what you need to do is just plug 1,000 in for x and then add 2,000 to it. So let me clear this out. So 2,000 plus 0.06 times 1,000. So she's getting $60 from the 1,000 in sales added to her $2,000 base salary. She gets a total of $2,060. So we change colors. So plugging 1,000 in for x, her gross pay is this. I'm having issues with this. Is $2,060. So let me change colors. Now she wants to see how much money she'll earn if she sells 3,000. So again, use your calculator, and you can grab all of this, copy the equation. Maybe you can't. If you do the shortcut on your calculator or on your keyboard strokes, Control-C or Apple-C, I think it is, and then you can just grab that equation and change it to 3,000. So she makes $180 off of the 3,000, the 6% commission, and adds to it her base salary of $2,180. So $2,180. So we're going to do this again with 5,000 and 7,000, so I don't have to go back and forth. I'll just, so at 5,000 she makes 2,300, at 7,000 she makes 2,420. And I want to point out another way you can answer this question, and use the calculator and the table. Is what I'm going to do is just change this to y equals the expression I came up with, and then what I can do is change it to a table. Now the thing is, you want to be smart about your x values. Like, you'd be hitting enter for a while. You can say, okay, well, x is 1,000, 3,000. You see how much faster this would have been. And if we did that one more time, 9,000, I'm answering the next question. She would have to sell $9,000 worth of stuff before she made a salary of $2,540, which is this question right here. So that's how you can use your tables to answer that question. How much must she have in sales is $9,000. Is answering this question right here. So again, pause the video, write down what you need to. This problem comes straight from the book, so if you just want to hit exercise 1 from 1.7 to reference it and then answer the question. Okay, so exercise 2, read it, comprehend it, and then we'll move forward with the problem. So this individual is hiring a plumber. One plumber charges $60 just to get out there, and then $35 per hour. Now, my clue to students is when you see this per in here, the hour is what changes. So it makes sense that you're going to multiply 35 by however many hours they're staying there. And then the $60 is like the y-intercept. It's your starting amount. So you start there no matter what. Whereas the second plumber, I'm going to create the same equation, it just charges $45 per hour with no other fee. So Patrick estimates that the time it would take to finish the job is 5 hours. So which plumber charges less for 5 hours? Again, you can just go to a calculator and you can plug in 5 for each of these. So this is one plumber. I don't know, maybe I'll label this as plumber 1, and this would be plumber 2. Sometimes we use subscript to emphasize that. So you just have to figure out what 60 plus 35 times 5 is. Whereas this problem, plumber 2, is just 45 times 5. If you're confused where I'm getting 5 from, that's the time it's going to take to finish the job. Go to your calculator. We don't need that anymore. Type it in. So $235 for plumber 1. $225 for plumber 2. So back to the question, 235 and 225. Now we have to make sure we answer the questions being asked. Which plumber charges less? So which one is less is 225. So plumber 2. And then by how much you want to subtract the difference. So subtracting that, and you could say by $10. That's how cheaper it is. Again, I probably should have mentioned it. You should have paused the video earlier if you need to write anything else down. And then, as I move forward, pause the video. Make sure you comprehend the question before trying to get it. You can even try it on your own if you want. So I don't teach percent off in the traditional sense that some other math teachers do. I like to explain it this way. If something is 40% off, my question to you then is how much are you paying for? Well, the original item is 100%. So this is if you paid full price, 100%, 100%, 100%, 100%. And if we take 40% off, it makes sense that you're paying for 60% of the item. So instead of doing, like some teachers go through all the work and they say, oh, take the number that they give you, which is X, in this case like $79.99, and then multiply it by 0.4, that gives you the percent off, and then subtract it from the original price. So you can see I have X's on here twice, which makes perfect sense. But let's look at it this way, is these are like terms, correct? Same variable. So this is 1x minus 0.4x, which equals to 0.6x, which is the same thing as 60% that you're paying for. So it actually makes more sense if you make a table. I'm going to make it this way because I want to go left to right. So you have the original price. So then you're going to do 60% off. So I'm saving you a step by teaching you this strategy. And then what you're going to do is take that value, that 0.6x, and then we're going to multiply it by the tax, which I'm going to explain the same way. If you're paying 6.5% tax, that's you're paying times 1.065, because traditionally you may have learned, you multiply that value and then you add it to the original. Well, if this is 1x plus 0.065, I hope you're recognizing where I'm getting this from. So you can just make a table this way and then use a graphing calculator, or any calculator for that matter. So let me show you how to use Desmos, since everybody has access to Desmos. Is you can just make a table, like I showed you, y equals 0.65x. Sorry, the y got caught off. Oh shoot, that was supposed to say just 0.6x. Sorry about that. Change it to a table, and then you can make any value you want for x. So $79.99. What's the next one? $16.49. And then the next one is $32.79. And then the last one is $15.75. And let me just delete this last one because we don't need it. So you can see that there will be paying $47.99, $9.89, $19.67, and $9.45 to finish up this table. But I'm kind of running out of time here, so I'm not going to copy that down. You just saw it. You should write it down though. So now what I can do is make a new equation, and I can actually just copy everything over, like y equals that 0.6x times that 1.065. Again, change it to a table, and now I can plug in anything I want for the original price. $79.99, $16.49, $32.79, and $15.75. So these are the values they gave you. And notice that the tax is going up by about $4, which should make sense. Make sure your answer makes sense as you answer these questions. A little bit more than the discounted price. So these are your last 4 answers on this. Now I'm going to stop the video, and I definitely need to teach the very last example. So I'm going to finish that up here shortly.